Good morning, everyone, and a warm welcome to this seminar. My name is Diane Newell. I'm a professor emerita with the Institute of Oceans and Fisheries, the Center for Indigenous Fisheries, and the Department of History at UBC. I wish I could say that I had something to do with Loren's being here today, but unfortunately I didn't. But I'm very pleased to have the opportunity to introduce her as such an intriguing and interdisciplinary scholar in fisheries in the broadest sense and oceans, and one whose works takes deep dives into the past and in doing so teaches us much about the joys and the pitfalls of creating, assessing, and working with historical data. I say historical, but she's also worked in the prehistoric period. Her work ranges from long-term changes in marine populations to footprints of loss, risk, declines, resilience, historical overfishing, historical reconstruction, trafficking networks. She is also published in the area of practices and the uses of archival material, including how to approach gaps in the data. Her publications are co-authored with some of our incoming, former, and present IOF researchers, including Skye Augustine, who will be joining us in the summer as our new Indigenous fisheries scientist, and Nathan Bennett, as well as Daniel Pauly. She has published with the late Danny Vickers of the History Department at UBC. The title of her talk even reflects the 10th anniversary theme of the UBC Institute for the Oceans and Fisheries. So to Loren, I say, come on in. Learning from the past to reimagine the future of oceans and fisheries, historic marine ecology, and in the Northeast Pacific. Thank you, Loren.
Okay, well, thank you for that very lovely introduction. I wish I could be there in person. I did spend about 2 years in Vancouver as a postdoc at SFU, so got to spend a lot of time on campus when I was there, and I'm happy to be sort of recently relocated back in the region. I've been at UVic now for about 4 years. And so this talk is a summary of some of the work that I've done since coming back to British Columbia. And so I've put it into the context of the series Learning from the Past to Imagine the Future of Oceans and Fisheries. But this will very much focus on history and what we can learn from historical marine ecology in this region. So thinking about the future of oceans and fisheries, there's lots of different ecological contexts and social goals, contexts that include marine mammals, finfish, invertebrates, and goals that include things like the recovery of historically exploited species, sustainable fisheries management, putting these in the context of future climate resilience, and then Indigenous resource management as overlaying perhaps all of these. And so I think about each of these modern management contexts as being shaped by processes that have happened over time, both in terms of the social and ecological history. So I think about things like changes in marine species and ecosystems, the climate histories of particular locations, and then the often really unique social histories that have led to the context that we're thinking about decision making for the future within. And so my interrelated research goals with the work that I do, and in particular the work that I'll be talking about today in this region, are to think about those layered systems and how they shape what we're existing in and deciding about for the future. So things like linking species and ecosystem change over time, linking fisheries and climate history, and then connecting historical ecology, which I think of as change, to ecosystems and environmental history, which includes more of the social story, to consider both of those components as drivers of change in these reciprocal systems. and then to connect those results back to management goals. And so in the talk that I will give today, I will talk about three examples that I think highlight some of the things that we can learn from the past and how those connect to some of those goals. So I'll start by talking about linking species and ecosystem change over time, and we'll go on a small trip to California and think about California sea otter recovery. Then we'll move north to Alaska and think about linking fisheries and climate history, thinking about Pacific cod, and then connecting historical ecology to environmental history, considering both social and ecological stories. We'll think about clams here in British Columbia. So getting started, the first example that I want to talk about is focused on sea otters in California. And this was a project that was led by Terry Nicholson at the Monterey Bay Aquarium and included collaborators that had expertise in otter ecology, historical ecology, and ecological modeling. And so otters are a well-known ecological keystone species in kelp forests, and this has been known for decades with increases in recovery of sea otters in particular locations and islands in Alaska, leading to consumption of urchins, which then resulted in more kelp and the biodiversity associated with that. So differences between islands with otters and those without in Alaska help ecologists to define this fundamental concept of keystone species in the 1970s as those otters were beginning to recover in that geography. Now, 50 years later, otter recovery has been more widespread, and we can build on this and ask questions about how this recovery has affected kelp forests at larger spatial scales. And so for this project, we were focused on the spatial scale of the coast of California, where sea otters, like everywhere else in the region, were hunted to near extinction. In California, they were thought to have gone completely extinct until there was a discovery of a remnant colony in 1915 by a lighthouse keeper off the very remote coast of Big Sur. And so that was later reported on here in Life magazine in 1938 with the title "The Extinct Sea Otter Swims Back to Life." The population continued to increase. This is showing that that increase from 1915, when that small colony was found, to 1990, and then it's increased until today, where it's over 3,000 individuals. It was when it was discovered, when that remnant population was discovered, it actually had already achieved protection under the 1911 Fur Seal Treaty, which covered all fur-bearing mammals, including sea otters. And then later in the US, it was protected under the Endangered Species Act and Marine Mammal Protection Acts. And so the population increased as well as the range. And so this map is showing that change over time. We can see in the center, 1938 is where that remnant colony was found in Monterey County, and it expanded out from that. There were natural population increases as well as directed reintroductions, particularly in the Monterey Bay region and Elkhorn Slough by the conservation science staff at Monterey Bay Aquarium in collaboration with others. But the range has really stayed restricted to central California. So it's bounded to the north by the San Francisco Bay, and then to the south by Point Conception, which is shown here. And so the question that we wanted to ask with this system was, has otter recovery over the last century affected kelp forests? And so addressing this question requires thinking over long timescales. And so finding sources that might give us insight into that. And so for otters, that's quite easy. Otters were valuable. Many historical sources documented the scale of exploitation, and we know we've tracked the recovery quite well. Kelp is another story. So kelp aren't charismatic in the same way that otters are, and they weren't documented as extensively. We do have some historical sources for kelp. We have these sort of beautiful descriptions from the 18th century natural history descriptions, often alongside other more charismatic species like the now extinct stellar sea cow. This description says the floating tops of these plants were streaming on the surface of the water with the tide, and they made a very beautiful appearance. They show up sometimes on nautical charts from the 19th century, in particular in regions that were heavily trafficked by sail. Like this spot in Southern California, Point Loma, we can see the kelp bed and then the passage through the kelp, which was denoted in this chart from 1894. But this neither of these is really at the spatial scale that we're interested in. This changes in the early 20th century when kelp became valued commercially as a product for war. They were valuable in particular in World War I as a source of chemicals, including gunpowder. And this sort of infomercial from the Hercules Power Company talks about that and lists some of the chemicals from kelp that were possible to extract. And so, in the process of the possibility of harvesting kelp on a large scale, there were government surveys that were undertaken at large spatial scales. So, between 1910 and 1912, the US government sponsored surveys along the coast of North America to support this possible industrial harvest. They were published in this report by the US Department of Agriculture called Potash from Kelp. And alongside the text, there were these series of maps that show where kelp were and other descriptions of those kelp beds. And so this now becomes something that we can use to think about the change that we're interested in on the scale that we're interested in looking at it. And so, if you'll remember the history of sea otter populations, kelp baselines in 1911 are actually really, really useful because this was when we know otter populations to be perhaps at their lowest. And so, these potash maps document the entire California coast, which is about 1,600 kilometers long at this point when otter populations were low. We see some of those here, some extracts from those from northern, central, and southern California. And I'll just point out that alongside the distribution, so we have these polygons that show where the kelp were. There's also information on the density, and then each of those numbers, it says number 17, 18, etc., was supported by text, and so it described the text component of this described the species and more information on the density. And so this gives us a really good sense of kelp baselines, which we can then compare to what has happened since then. So we compared those to modern kelp from aerial surveys collected by the California Department of Fish and Wildlife, and we have this then and now comparison of kelp. And so I'll show you what we found from that. But first, I just want to orient the coast because this is what will show up on the x-axis of those charts. So the California coast is about 1,600 kilometers long, and we started in San Diego and called this 0 kilometers at the Mexican border. 400-kilometer marker is the Santa Barbara Channel, which marks the boundary between Southern and Central California. At 800 kilometers is the Monterey Bay, which is the center of otter abundance today. Northern California at 1,200, and then the Oregon border at 1,600 kilometers. And so in the next series of slides, you'll see this flipped on the x-axis from 0 to 16. And so this is our analysis of that comparison of then and now in terms of kelp area expressed in hectares. So we see San Diego to the Oregon border, and the blue indicating the kelp distribution in 1911, and then the green showing it today. And so just as an example, this area that I'm showing you with an arrow is corresponding to a spot in Northern California. And we can see that this area historically had kelp, but doesn't anymore. So this is to visualize the information that we can extract from those sources. But what we're really interested in is change and the difference. And so the next slide I'll show you has the difference between these so we can see where kelp has increased and where it hasn't. And so this chart is the same, this graph is the same orientation with San Diego to Oregon. And now we're seeing the kelp canopy expressed as change over time. And so we can see here where it's increased and where it's decreased over the last century. And this, I think, highlights some really interesting patterns, which is that we found decreasing kelp in Southern and Northern California. So in Southern California, it's about a 50% decline. In Northern California, it's about a 60% decline. And then in Central California, where sea otters have recovered, we instead of a decline see an increase. We see about a 58% increase. And so, this is really interesting and tells us something about long-term change. But otters aren't the only thing that affect kelp, and so we wanted to look at drivers of change in statewide kelp canopy cover with a little bit more detail with considering more factors. So I'll show you some of those drivers. The first one that we've been talking about, of course, is otters, and so this is otter density on that same scale along the. So this is a chart showing the spatial distribution of otters in California, which I've been describing. This is now the data that support that. But we also looked at seafloor substrate along that same California coastline, human population density, and temperature, as well as a few other factors. And for all of these, we looked at the relationship between the driver and the outcome, which is the kelp change. And so we found that sea otters corresponded with kelp gains at higher population densities, and that these other factors, seafloor substrate, temperature, and human population density, resulted most strongly with kelp canopy losses. And importantly, temperature was a factor across the entire California coast, not just in Southern California. I won't get too much into the weeds here, but there was modeling work that was done with these data, and sea otter density ranked as the primary driver of kelp change across all of these different variables that we looked at. So in conclusion for this piece of the story, it, I think, shows that historical sources can help to assess the effects of recovery over large spatial and temporal scales, building on some of this fundamental work in kelp ecology. And that using these sources, we find that otter recovery buffered other impacts like warming waters, which have been an impact along the entire coast, and that restoring historical abundance of key species can improve climate resilience. Okay, so I'm going to switch gears now and move north to think about linking fisheries and climate history by looking at Pacific cod in Alaska. And this was a part of a large project born out of the Pacific Cod Historical Ecology Working Group, which is a collaboration among historical ecologists, archaeologists, anthropologists, climate modelers, and fisheries scientists. And it came together in response to an event that happened, a series of events that happened in the 2010s that were nicknamed the Blob. So this was a series of marine heat waves along the west coast of North America, which had many impacts, including on marine fisheries. And Pacific cod in particular are sensitive to temperature across their life history. And this series of heat events led to a population crash with a closure of the fishery in 2020. And up until this point, the fishery was considered to be well managed, but there were discussions of the idea that this collapse may have had precedence in history, and part of that comes from the name. So the Aleut name for Pacific cod translates to the fish that stop, which suggests that there might be inconsistent availability over time. There was also some thought that the 1930s might have been a possible historical period of decline. But the Pacific cod story and the history of the fishery, surprisingly to me at least, was quite poorly studied because it was in the shadow of both the Atlantic cod fishery, which has been really heavily studied, and then the Pacific salmon fishery here on the West Coast, which has likewise been the focus of a lot of research. And so we started with some, I think, quite simple questions here, which is just simply, what is the catch history for Pacific cod? And is there evidence for that decline in the 1930s? And then if so, what are what's the different evidence for different drivers of change. So thinking about social changes, overfishing, and climate change as main drivers. And so the commercial cod fishery, which is what we focused on here, began in 1860. This was a schooner-based fishery with fishermen largely leaving from San Francisco and the Puget Sound. And the large schooners deployed these smaller dories, which we can see an example of here, sort of overloaded with cod to catch fish, which were then dried and sold as salt cod. And so the catch reconstruction confirms this period of decline in the 1930s. This is showing the history of that commercial salt cod fishery from 1860 to 1950 in metric tons. And while there were a variety of different smaller fisheries within that, the American schooner fishery was the largest. And we can see that the catch increased up until about 1919 and then began to decline during the 1920s and 1930s. So we do see this period of decline that was suggested previously. And then thinking about the different drivers, there were a lot of different things happening in the fishery to influence the catch. So, for example, markets and competition. So, as I mentioned, this fishery was in the shadow of the Atlantic cod fishery. This also translated to the markets being really dependent on trends in that larger, more desirable fishery. And then on the West Coast, markets for Pacific cod were limited to west of the Rockies. And then there was strong competition with Japanese caught fish. This was linked to really thin profit margins in the fishery. So there was a low price for the product relative to Atlantic cod. And schooner owners complained often in the documents that we read about the high cost of wages relative to Japanese competitors. So really thin profit margins that were influenced by shifting and somewhat fickle consumer demand. So there was a sharp drop in demand after 1919 when the Atlantic cod markets reopened after World War I. And then in the 1920s, there was a shifting preference away from salt cod towards fresh and frozen products. And then finally, changes to fishing technology resulted in a shift away from schooners towards trawlers, beginning with the Japanese, but more fully in the 1940s. So there's clear evidence across these multiple factors that there were social changes happening in the fishery that would have had impact on the catch and likely caused part of the decline that we saw in the 1930s. But it's not just a social story. So while it might be tempting to say that all of these factors align to cause the end of the fishery, there's also, I think it's a more complicated story. So there's also descriptive evidence for declines happening in the water, including observations of declining abundance, distribution, and body size. So observations like this one from 1919 saying that the inshore banks began to show signs of depletion. In the 1930s, observations of schools that were badly scattered. And then I think really interestingly, there's this 9-year period where there's a decline in average weight. And so this newspaper article is reporting on that retrospectively, but we also have year by year data that supports this decline in body size. So there were real changes that were happening in the water that affected the fishery. There's also some quantitative evidence for depletions. So this is a map showing where this fishery took place in the Aleutian Islands and Bering Sea primarily. The Shumagon Islands were a location where the fishery had been really intense for kind of the longest period of time, and we found the fisheries data in this region showing declines in catch per unit effort, which is a metric of relative abundance in this intensely fished area. So this suggests that there might have been localized depletions happening in this. This pattern and this trend doesn't bear out when we look at this across all regions. So this is now showing the catch per vessel ton across the entire fishery, and that's a pretty flat trend. So we don't see that overfishing was happening at the regional scale, but there might have been localized changes that were happening. Okay, and then finally, what about climate? I started this talking about the idea that there might have been temperature impacts on cod in modern times. How does that look when we think about this period in the 1930s? And so the question being, what are the sea surface temperature trends during this period that we're thinking about, catch increase and catch decline? And so we looked at sea surface temperatures during this time period in these locations and found that, in fact, sea surface temperatures were anomalously high in the 1930s, which aligns with this period of catch decline. So we see anomalously high temperatures in the 1930s and anomalously cool temperatures in this period of catch increase leading up to that. So what is all this? I have one more here. We also looked at this spatially. So this now is showing the temperature difference between the period of catch decline and the period of catch increase that I just showed you that time series for in the last slide. And what this is suggesting is that there is warming of up to about 1.5 degrees Celsius across this time period. So strong evidence of warming in this 1930s in the region, 1930s period in the region that we are thinking about. So what does this tell us overall? We found evidence of cod catch declining in the 1920s and 1930s, which had previously been suggested. There were social changes in this time period that may have affected the catch, but it's also a more complicated story. There's abundant evidence for population declines with support for overfishing, perhaps as a local driver, and evidence for some climate drivers at a more regional scale with warming in this period, possibly affecting productivity. I think this is an interesting story because it is so complicated. There are complex drivers of change that are certainly interacting. So there's possible synergies among the social and ecological drivers. So, for example, overfishing coupled with climate stress might have reduced recruitment and resulted in population declines. On the social side of things, declining fish size could have led to inefficiencies in processing, which would have led to higher wages for the same product. So it's not possible to tease out the relative weight. I don't think of each of these factors, but I do think it's clear that there's interactions among them. And I think we can think about this as perhaps an ocean analog to the Dust Bowl, which is a well-known phenomenon in environmental history that has similar complex social and ecological interactions in the same time period associated with this warming in the 1930s. So the same warming existed in the oceans, with the 1930s as a known period of warming around the world. This graph here is showing global temperatures, and the 1930s we can see as this warmer period of time. And so climate histories in marine fisheries are poorly understood, and I think there's opportunities to investigate these linked social and ecological changes in fisheries in different geographies, in particular in this 1930s period. And then finally, linking this back to modern fisheries, I think we need these climate analogs from the past, in particular because there were expansions in global fisheries that began in the 1970s as exclusive economic zones were expanded and established, and the nationalization of fisheries led to really rapid capitalization of those fisheries. And this happened in the 1970s during this cool period, which has implications for fisheries in different ways, in different contexts. So these climate analogs from the past, I think, are important because this 50-year period of modern fisheries doesn't really provide enough insight into how climate affects fisheries productivity. So as temperatures increase, I think it's useful to look farther in the past to these climate analogs. Okay, I am going to now move us closer to home here in BC and talk about clams and talk about connecting historical ecology to environmental history, considering both the social and ecological components of those linked systems. And so this again is a collaborative project that includes Skye Augustine, who is a faculty member at UBC, as well as Marco Hatch at Western Washington. And it was led by Patrick Hayes, who is a postdoc here at the University of Victoria. And this collaboration was sparked by the needs of the Sea Garden Restoration Initiative, and Bryant Delroy, who helped us along with this, with getting this project started. And so sea gardens in the Pacific Northwest, I think, are a fairly well-known phenomenon at this point. They are constructed in intertidal zones by building walls to improve habitat structure for invertebrates, in particular clams. Tending practices of these gardens include harvesting select clams, transplanting clams among sites, and returning shells to beaches after harvest to continue the improvement of the habitat structure. And they've been shown to increase clam size and productivity. They are culturally significant in the Pacific Northwest, with tending of sea gardens providing an opportunity for communities to connect as elders share knowledge of these systems. But active tending of sea gardens was disrupted by colonial practices and has been paused in many communities. And there are ongoing efforts to restore clam beaches and tending practices with many different institutional supports for that, including the Gulf Islands National Park Reserve, which is the partner that we started off with in this project. These efforts are grounded in Indigenous knowledge and focused on traditional harvesting spots that once had high clam densities. And they are supported by extensive ecological and archaeological research that's been ongoing for the last 2 decades in these systems. And so this work takes a historical archival research approach that's aimed at documenting the colonial impacts at that point of transition in the late 19th and early 20th century. And so the two questions that we asked were, in what ways did colonial practices dispossess indigenous clam tending, and what were the ecological impacts of the settler colonial fisheries? And the goal of this work was to aid restoration efforts in sort of two ways. The first by helping to identify ecological baselines, and the second by providing documentation of dispossession that can potentially support Indigenous reclamation of these ocean spaces. So disruptions to ancestral clam tending happened in the context of widespread disruptions to Indigenous cultural practices and communities. And within that broader context, we categorized those disruptions to the clam harvesting in four key aspects. And I'll just really briefly talk through these. Each of these has many stories and many really interesting specific interactions that happen. But at this level, I'll just talk briefly through each of these so that we have a sense of what those were. The first has to do with management. So under ancestral practices, sea gardens were commonly held by individuals or family groups. In this transition to management under English common law, there was a guaranteed access by the public, which incentivized rapid harvest and overharvest of these systems. The BC government retained the right to lease beaches for exclusive harvesting, and there are many cases of applications that were sometimes approved and sometimes not for this, but always the approvals were always to settlers and never to in the documents that we reviewed, never to Indigenous communities that sometimes petitioned for this. And then the Department of Fisheries could also close beaches to harvesting in response to overfishing, which had the same impact in terms of dispossession and loss of access. Second, thinking about the harvesting itself. So Indigenous communities harvested selectively and at relatively modest rates. This short video here shows New Chalmouth clam diggers in the 1920s. In contrast, the commercial fishery was intensive, using harvesting methods that destroyed beds, sometimes things like fire hoses, and moved rapidly among clam beds. There was a description of a moving clam barge, for example, that really rapidly was able to move from place to place. And DFO itself noted that these practices led to, quote, taking all that could be obtained in any one place with a promise of other beds to be had for the trouble of moving. Processing was also quite linked to to these systems. So traditionally, clams were preserved for local use or trade. Instead, the commercial fishery channeled clams towards international markets with canneries that focused on generating profits. And the canning industry itself was a major driver of exploitation, and this was almost entirely controlled by settlers. Where near to where I am talking to you from, the Saanich Canning Company here on Vancouver Island devastated clam beaches in its vicinity before it closed in 1942. And then finally, shell use. So shells were commonly returned to beaches to help improve the sediment structure and the productivity of those beaches. And instead, the commercial clam industry commodified and sold shells as a byproduct of the canning process, for example, grinding them down and using them in chicken feed for road building and as grit for making stucco. And then there were also cases of settlers seeking to mine existing deposits of clam shells near indigenous communities. And so, under the colonial system, these shell deposits could function to extend land rights for First Nations. And so, this was a direct affront to that process as well. And so across these different components of the clam fishery, the commercial clam fishery really rapidly disrupted this system that had been able to maintain high productivity. So with the ancestral clam tending, the community management promoting tending, harvesting at sustainable levels, clams being consumed fresh, traded, or processed by drying, and then the shells being reused and returned to the beaches led to the beaches being maintained with high productivity. Instead, under the commercial clam fishery regime, the government management disrupted this tending practice. Intensive harvesting exhausted beaches. The clams were processed for canning for export. The shells were commodified and sold, and this led to clam populations being depleted and the fishery being unsustainable. And so we documented as well some of those impacts and this rapid ecological degradation. And so I'll just highlight some of those as well. So we found in DFO's record itself some evidence for declines in relative abundance. So this is from Seal Island, which is shown on this map here with inside the red circle with the number 4. This is on the east coast of Vancouver Island. This is a really important site for clam harvesting. And so this shows catch per tide declining from about 270 to 70 kilograms in about a decade under DFO management. Similarly, information on clam density in this same location shows the decline of clams by about 85% in this site. And so today the beach is still controlled by DFO, and it hasn't shown signs of recovery back to these historical abundances. We also see spatial shifts that demonstrate decline. So this is the same map now shown in color with these colors representing DFO's different reporting units. And so when we look at landings data, we can see shifts over time. So the industry initially focused on the Lower Mainland and southern Vancouver Island, shown here in blue and purple. So we can see that on this graph of landings over time. And it then moved northward, and we see a movement towards the North Coast mainland and the Central Coast, shown in the graph in blue and red, as those southern BC populations of clams were depleted. Finally, though, at the same time, we see a legacy of Indigenous tending in the context of these big changes that were happening. So, a DFO report from 1937 looked at the beaches that had been supplying the Saanich Canning Company, and so it categorized those as heavily depleted, which was most, moderately depleted, or abundant. And those that were still abundant in the 1930s had continued to be tended. So, for example, the large beach shown here with the number 1 is at the Cowichan Wharf, located directly beside the Cowichan First Nation community that continued to tend and harvest it. And DFO observed that this beach remained productive and noted depletion was, quote, not as great as might be expected. There was a similar legacy outside of the scope of this map here, but a similar legacy of continued ancestral tending in the Broughton Archipelago, and this region demonstrated unusually stable fisheries from the 1930s to the 1960s. So, despite these changes that were happening, there was still indigenous tending that was maintaining productivity in some locations. So, in conclusion, this work showed the ways that settler colonial clam fisheries in BC disrupted ancestral tending. It documented some of those significant and lasting degradation impacts, including serial depletions and rapid declines in clam populations. Some of this ecological baseline information can help to provide targets for restoration, but I think perhaps more importantly, the social history helps to prioritize active management and Indigenous stewardship as compared to the practice of beach closures as a conservation policy. And so I've only really briefly touched on some of the documents that Patrick collected and analyzed, but he and I worked together with some students to create a metadata file essentially that summarizes and makes all of these documents available to nations and tribes for use in particular contexts. And so there's continued work, including collaboration with Sky and others to put these documents to active use. Okay, so putting this all together, what have we learned across these different examples, and how does this apply to our goals for the future of these ocean spaces? So historical analyses can show that species recovery can improve climate resilience in some contexts, like the story of the otter. The story of Pacific cod shows us that modern fisheries are moving into uncharted territories with respect to warming waters, but we do have some opportunities to learn from the past with these climate analogs. And then finally, archival work supporting work in other fields that has been really important to document the efficacy of Indigenous stewardship in fisheries. And with that, I will stop and look forward to comments and questions that folks might have.
It was a wonderful talk, Loren. Thanks very much. It was well presented and all kinds of interesting information. On the question of the clam gardens, I was wondering how significant the role is of returning the clams. I mean, that's certainly a social component, a cultural element of returning back to the environment. But does it, in terms of, say, the significant factors that provide, improved clam productivity, is the return of shells really a major component, or is it sort of more of a minor component in terms of, maybe it increases the porosity of the habitat and all that kind of stuff?
Great. Well, thanks. Yeah, thanks for the comment and question. I have to say I'm not an ecologist working in the system, so I don't know that I can give the most robust answer to that. But I do think it is likely a combination. I think if you visit places where this has been a part of food consumption for long times, the piles and piles of clamshells that exist, I think are useful in thinking about sort of the extension of the land as one impact in terms of how does this impact the productivity of clams? Is it more or less important than other tending practices? I don't know the answer to that, and I rely on ecologists that I collaborate with to sort of answer those pieces of it.
It's a related question, maybe. Much of the clam productivity for colonial commercialization is now clam gardens. I mean, clam aquaculture, with manila clams. And so the wild clam fishery, I think, is reduced quite a bit compared to those days. No, shown in the graph.
Yes, yeah, and we
Okay,
did end the this particular analysis. I think in the 19, I don't remember exactly when it ended, in the 1950s or 1960s, and didn't continue it to today. There were also big changes that happened with changes in the species that were harvested with introductions of non-native species. So yeah, big declines in that fishery as well. And so we were focusing most on that period of transition more so than the continuation. But those data do continue to modern times.
but so do you think that some of those have recovered now, some of those highly depleted areas, or?
No, I don't think so. I mean, so we've only looked at it in particular locations like this, like Seal Island, for example, and that has not recovered. And so the impetus for the project was some of the restoration work that is being done in the Gulf Islands, and they're really interested in knowing, what sort of information exists in terms of density in the past. And according to, I haven't been out to some of these locations that they're working in, but no, I don't think so, according to their observations.
Thanks, Loren. Maybe before we go continue with the online participants' questions, are there anyone who wants to ask the questions in the room? Yes, please.
Will the mic hear me?
Can you hear the questions okay? Okay, here's it.
Yeah. So I was curious on the otter study. You mentioned how temperature was in effect throughout the range, and the otters were really important, but you also mentioned that the otters really only recovered in central California. And so I was wondering if the study shed any light on what might be constraining the otters, that central portion of California, rather than a recovery throughout the state.
Yeah, no, that's a good question. We weren't looking at change in otter populations over time, but I do know that, with just from collaborating with folks at the aquarium who've really been leading both the reintroductions and then the work around the dynamics. There are a few things. So San Francisco Bay is a big geographic feature that has stopped the extension of the range to the north, and there's work that's been done on shark predation at the ranges, at the sort of outermost ranges of the otter current range to the south. I know that there were some efforts to reintroduce otters farther south in Santa Barbara, and I think those may be ongoing. I haven't followed it recently, but there's also been pretty strong opposition to that among fishing communities in that region. And so I think in addition to the sort of physical feature of Point Conception, it's a really sort of different oceanographic regime north and south. There's also sort of social resistance to that, in particular in Southern California. But there has been lots of work from the ecological side of things in terms of what's concerning that. And so the Monterey Bay Aquarium has this reintroduction program, which is based on rearing of baby otters that have been orphaned, and so there's lots of data associated with that over time. But my understanding is that it's those two big features that have constrained it up to this point.
Thank you. Next, we go back to the online participants. I think the next in line is Maggie. Maggie, would you like to ask the questions yourself?
Yes. This was such a great talk and such a treat. I'm curious if you have thoughts on if your clam work has angles related to climate resilience. I know that clam gardens buffer heat as well. So I'm wondering if there are data sets that you're exploring that will kind of touch on similar points that you made in your talk.
Yeah, no, that's a super point and observation, and we haven't up to this point considered those linkages, but I think they're really really important. And sea level rise and sort of storm buffering. I think all of think there's probably many different angles to think about that. And yeah, I think it's a great idea. we haven't gone there with that, but I think it makes a lot of sense.
Thanks. And from the room, is there anyone who wants to ask a question? If not, then we'll go continue with the online questioning. Next, I'll give the mic to Andrew. Andrew would like to.
Yeah, hello, Loren. I hope you can hear me, but I really enjoyed your talk. I really like how you're using this detective work and going through those records, the archival to rebuild the past. I think it's really insightful and very helpful. I was also kind of interested in the otter part of the story about why they hadn't moved further north. And we're just wondering, have you explored using archaeological data to look at where otters used to be, let's say where codfish were historically, and seeing some of the changes that have occurred? Because I think one of the important things is that some of the natural environmental shifts that have occurred for thousands of years, I think there's records of that in the archival record. So I'm just wondering if you looked into that.
Yeah, no, thanks. It's a great comment. In terms of the otters, I did try to synthesize or pull all of the information that we could on archaeological records that had been put together, and it's a bit limited. The cod story is there's a ton of great information from archaeological records, and in fact, the person who pulled the group together, Catherine West, is an archaeologist, and she has some really great sort of analogous observations of changes to body size in that archaeological record over time. And so I think it would be great to sort of pull those together. We've done some sort of descriptive work around trying to pull those data sets together and talk about the relative value and what you can learn from them. But I think actually trying body size is a metric that sort of holds up across these different types of pieces of the detective work, and so thinking about pulling those together, I think would be really useful. I think it's I think with all of these different sources, it's what was left behind, and is there enough of it to be able to say something with any kind of certainty? And I think for the cod story, I think there probably is. For otters, we didn't really find it.
Next, Amanda, please.
Yeah, hi, Loren. Again, you can't see me, but thank you. That was fabulous. I wish you were here. It'd be great to talk some more about some of these ideas. I'm really glad that you highlighted seaweeds, because I think globally we're not paying enough attention to what's happening to seaweeds and realizing that they're under significant pressure. So I'm wondering whether you know of, there's a new IUCN seaweed specialist group that I'm helping to support. And I'm wondering if you know of other significant data sets on the history of seaweed distributions beyond the wonderful ones you highlighted. Do you know of any other data sets around the world that might be of value to the seaweed specialist group as they try to figure out what's been going on with their taxa?
Yeah, I love that question because it's not easy. It's sort of thinking about, who would have cared and why in different places and different times. I think, the industrial harvest wasn't restricted to the West Coast of North America. There were other places where that was going on. And so likely there's similar sorts of surveys that were done in other places. Another big source that a lot of people are starting to think about is one that I touched on really briefly, which is nautical charts. And those were made not consistently in all places, but in places where there was often a colonial interest in sort of rapidly understanding the coastline better than somebody else. Those charts were made with a lot of precision. And I actually just had a student in the history department write a really nice thesis about the reliability of that source and where we could think about it as being useful and where it might be a little bit less so. And again, that wouldn't be for everywhere, but it would be for places that had sort of focused interest. So yeah, I would love to.
Could I put you in touch with the chairs of the new seaweed specialist group? Because I think your work would really delight them if you're willing to let me connect you.
Yeah, absolutely. I would love that.
Thank you. And I just have one more question. And that is, what are you planning to do next? Like, this is fantastic. Obviously, views as to what you've already accomplished, but what's the current focus for your historical work? If that makes any sort of chronological sense. So.
Yeah, I'm really enjoying being here in BC. There's so many questions and so many different contexts and species to work in. I'm working right now with some salmon data, which is sort of tiptoeing around that because when I first arrived, because it is such a complicated system, and so many different issues with sort of understanding change with sort of fluctuating dynamics. But I'm starting to dip my toe into salmon data a bit because there is so much of it and it's so relevant to modern questions. Also very interested in herring. There's sort of questions around management of Strait of Georgia herring that are, I think, informed by historical data. So working to pull together some of those documents. But very happy to collaborate. So if there are folks who are interested in working on systems and think there's a historical approach, I'm still sort of feeling my way into this space as well. But very interested in BC. I think it is a really great context to think about these questions.
Thank you so much, Loren. There are a lot of interest on your talk. Your talk is wonderful.